Just some vocabulary. We have isosceles triangles. Isosceles triangles have at least two congruent sides, and I showed a couple pictures up here with the two sides that have equal length. Isosceles has at least two congruent sides. So technically, an equilateral triangle is isosceles too because it has two congruent sides. And I think you saw that on some of the Alex practice yesterday, that like an equilateral triangle is also isosceles because it has two congruent sides. If it has exactly two congruent sides, then this is how you name the parts. So the first word here is legs. So the legs are the two congruent sides of the triangle. So like this is a leg and this is a leg. And it has this little tally mark here showing that those two match in length. So that'd be legs. And then vertex angle is the angle that's like different. So vertex angle is this angle right here. Vertex angle. And then we have the base of the triangle, which is the side that's a different length than the two congruent sides. And then we have base angles. Base angles are opposite the congruent sides, and they are the same measure. So base angles are congruent. Okay, and then we have a couple theorems here. I already touched on these, but just to kind of see them in the formal setting. The base angle theorem, this is also called isosceles triangle base angle theorem, depending on the resource. It says if two sides of the triangle are congruent, then the angles opposite them are congruent. So the angles opposite would be like opposite here, and it makes two congruent base angles. So angle B is congruent to angle C. And then the converse of that is if you have two base angles are the same, or if you have a triangle and two angles are the same, then the sides opposite those base angles are congruent. So opposite this and opposite this, you have congruent sides. So this side is congruent to this. Okay, and then examples here, name the congruent parts of each triangle. So here it shows this little tally mark, so that means that segment FD is congruent to segment ED to start. And then opposite those congruent sides are two base angles that are congruent. So this angle is equal to this. Angle F is congruent to angle E. Then for this one, it shows the two base angles the same. So angle T is equal to or congruent to angle W. And then opposite those base angles are congruent sides. So this side would be congruent to this. So TO is congruent to WO. Those sides are the same way. Okay, and then to the right, I got that down. It says, use this diagram to answer the questions, and it's going to talk about matching sides and parts. I'm going to use different colors to try to coordinate. It says AE is congruent to DE, then which angles are equal? So let's see. AE is congruent to DE, then which angles are going to be congruent? Well, this angle would then be congruent to this angle. So angle A would be congruent to angle D. Okay, and then it says AE is congruent to EB. Which angles are congruent? So AE right here, EB right here. Those two sides are congruent. Which angles would be congruent? Well, this angle would be congruent to this because those would be the base angles. So angle A would be congruent to this angle BEA. For the next example, it says two angles are congruent, then it asks for congruent sides. So let's look at this. Angle D right here is equal to CED. So this angle, so these are the two base angles. If those two base angles are the same, then these two sides are the same. So CE and CD. And then for this one, these angles are the same, then what sides are the same? So to identify these angles, I'm just going to connect the dots. So EBC would be this angle, and then ECB would be this angle, and then that would mean that this side is equal to this, so BE would be equal to EC. Okay, so in the next exercise, we're going to bring in the numbers. This is actually very similar to what you'll see on the test, and there's really good practice on Alex with this too. So all of these show isosceles triangles. It says find the unknown measure in the triangle. So for A, it shows that these two sides are the same, so therefore the base angles opposite those two sides would be equal, and then it wants to know the vertex angle as well. So if this is 50 degrees, then this base angle would also be 50 degrees. And then to find the vertex angle, like these three add to 180. So we can do 180 minus 50 minus 50. Just hold on. Okay, so these are both 50. Then we are going to find the last angle by subtracting those both from 180, because the angles of a triangle add to 180. So 180 minus 50, so minus 100, would leave us with 80 degrees. And then this is the angle here. Okay, then for the next example, shows two base angles the same, so therefore this side would be the same length as this. And it shows that this side is 5 centimeters, so then this one would also have to be 5 centimeters. Then for the next example, shows these two sides the same, so therefore these base angles would be the same measure. If this is 46 degrees, then this is 46 degrees. And then to find the vertex angle, we're going to subtract 46 minus 46 to get the missing angle, and that would be 88 degrees is left over, so that would be our vertex angle here. Okay, and D, it shows these two sides the same, so therefore these are our base angles right here, opposite those sides. For this one, we're going to start by subtracting 40 from 180 to get 140 degrees. And then since these two base angles are the same, it's going to split these degrees evenly. So we just do 140 divided by 2, and that gives us 70 degrees for each angle. Okay, and then E shows these two sides the same. That means these two would be the base angles. So if this is 63, this is 63. Then the vertex angle here, we'll do 180 minus the two 63s to find out what's left over to see what goes there. 180 minus 63 minus 63, that gives us 54 degrees left over. So that is what goes here, 54 degrees. Okay, and then for this one, they bring in a little bit of algebra. They show that this angle is equal to this, so that means that this side is equal to this side, and then we can set these equal to solve for x. So 3x plus 4 equals 22. Subtract 4 from both sides, 3x equals 18, divided by 3, x equals 6. And then on the next page, we're going to focus more on equilateral triangles. So when you're ready, just flip to the next page. Do a packet. I might have your... Okay, so on the next page, we're focusing on equilateral triangles. You probably are pretty familiar with what equilateral triangles is. An equilateral triangle has all congruent sides. So it looks like this, and then all the sides are the same length. Okay, so the corollaries to this, if a triangle is equilateral, then it's equiangular. If it's equilateral, then it's equiangular. Like if all the sides are the same, then all the angles are the same too. So if all the sides are congruent, then all the angles are the same measure. And the converse of that, if the triangle is equiangular, meaning all the angles are the same, then it's equilateral. And since all the angles of a triangle add up to 180 degrees, 180 divided by 3 equals 60 degrees. And so in an equilateral triangle, all the angles are 60 degrees. Okay, so the first example here, find the measures of angle PQ and R. PQ and R, it shows all the sides are the same, so therefore all the angles are going to be the same. Then to find each angle, 180 degrees divided by 3, divide it evenly, 60 degrees for each angle. Okay, and then find the length of SP for this. It shows all the angles are the same, so therefore, based on the converse, all the sides would be the same length. It shows a little 5 right here for this side length, so then this would be 5 and this would be 5, so ST equals 5 units. Okay, and then C brings in a little bit of algebra. Find the value of X and Y. It shows all the sides are the same, so therefore all the angles would be the same. 180 divided by 3 is 60 degrees, so therefore each angle is 60 degrees. Then from here, you can set each of these expressions equal to 60, y minus 10 equals 60, and x plus 5 equals 60 to solve for the variable. So we get add 10, y equals 70, x equals 55, like that. And it's just asking for x and y, so you don't have to plug in anything, we're done there. Okay. The next page, it takes it up a notch a little bit, makes it more high school over here, because I know that was too easy for a lot of you. You guys are smarter than this. So here we'll take on a little bit of a challenge. It says a measure of each congruent angles of an isosceles triangle is 6 less than the measure of the vertex angle. So find the measure of each angle. So first things first, I'm going to draw a picture so that way I can see it like all the way out. So I'm drawing an isosceles triangle. It says that's what I'm working with. Got the two congruent sides, the two base angles. Then I'm going to label this with expressions. So measure of each congruent angle, so these are my two congruent angles, of an isosceles triangle is 6 less than the measure of the vertex angle. So x minus 6, and then the vertex angle will be x. So it said the two congruent angles are 6 less than the vertex angle. So that's how I got this whole setup. Then I also know the angles of a triangle add to 180. So I'm going to add up all this and put it equal to 180 to solve. So we get x plus x minus 6 plus x minus 6 equals 180 degrees. Then from here, I combine like terms and solve for x. So combine all those, 3x minus 12, 180. We get x equals 64. Our problem doesn't ask for x, it says find the measure of each angle. So once we have the value of x, we need to plug it into the expressions and solve. So x equals 64, so the vertex angle is just going to be 64. And then here, I'll do 64 minus 6, 58 degrees. And then this one, the base angle is going to be the same as this base angle, so 58 degrees. Okay, second one for B, the measure of the vertex angle of an isosceles triangle is 15 more than the measure of each base angle. So again, I'm going to draw myself an isosceles triangle. Congruent sides, base angles. The measure of the vertex angle this time, vertex angle up here, is 15 more than the measure of each base angle. So this will be x plus 15, and then this will be x and x. And then from here, these three add to 180. There's actually really good practice with this on ALEKS too. And it's nice because it gives you the picture. On ALEKS, you don't have to draw it from scratch. Plus x. So I'm adding these three up, putting them equal to 180 degrees, and then solving for x. So combining like terms. Yeah, x equals 55. So it asks for the degree measure of each angle, so I have to make sure to plug this back in. So this means that each base angle would be 55. And then the vertex angle would be 55 plus 15, which would be 70 degrees, like that. Okay, so from here we're going to transition over to the homework. But don't get up yet. I want to